The ability of scientists to develop new drugs is hampered by the fact that testing on animals has limitations when it comes to use in humans, whilst testing in humans has the potential for dangerous side effects. But new technologies being developed around the world are now replicating human organs on chips, allowing scientists to test drugs in a safe and controlled way. I'm Dr. Goody Singh in London, England, looking at the potential for this type of bioengineering to improve the way that life-saving drugs are made.
Organs on chips replicate the tissue structures and biological function of human organs, and those being developed include lungs, hearts, kidneys, and livers. This then allows researchers a quicker and easier way to test new drugs for some of the biggest global diseases. Just outside London are CN Bio Innovations, an organisation who have created a human liver on a chip with the hope that new drugs can be found to help treat and cure liver diseases.
So the thing that's really different about this device is that we try to actually mimic the microarchitecture of the organ. This is a polymer disc, and it's got 300 small channels. The dimensions are such that when we organise liver cells into these channels, they form these sort of long donut-shaped arrangements of cells. And this is really trying to model the architecture of the liver, which is a very vascular organ. And
so there's lots of blood vessels.
Exactly, lots of blood vessels, and essentially your cells are arranged around these blood vessels. And then this device, this plate, you put 12 of these chips into the plate, and the plate enables us to flow the fluid containing various nutrients and oxygen past the cells to keep them healthy and functioning.
So the fluid simulates blood then?
Exactly.
So is that like having 12 miniature livers?
Exactly. There are 12 little organs that we can actually perform testing on. And once the chips have been inserted, the plate will then be ready for us to introduce the liver cells for the experiments.
One of the key advantages of the liver chip is that because it mimics the structure of the liver so well, the liver cells stay alive for several weeks. This means that the scientists can study in detail the impact of a new drug on the organ.
Many of the diseases of the liver or the toxic effects of drugs on the liver only build up over a number of days or weeks or months. Right. And so it's difficult to observe those types of effects or predict those types of effects if you're using a technology where the cells are only functional for a matter of hours.
After introducing a drug to the liver chip, the team can study the impact it has by performing the lab equivalent of a biopsy or a blood test. This allows them to test whether the drug is toxic or to see how successful the drug might be at treating disease. Reducing the dependency on animal testing enables Emma and her team to run a huge number of tests, gathering large quantities of data much more quickly before clinical trials begin.
So the test that we're doing here is it's like the equivalent of a biopsy, is that right, in terms of looking at a sample of tissue from the liver?
Yes, so Emma's taken one of the liver chips out of the plate in the lab, and you can see that within the scaffold there is a regular array of channels, and these are filled with liver cells. So in fact, the good news here is that the drug has had no negative effect on the cells. The cells in this image are very healthy looking.
So we're kind of bypassing the traditional route in a way because we're able to just do a lot more tests a lot more quickly.
We're really trying to accelerate the process of drug development by making it a lot more efficient, and particularly by enabling researchers to understand how the human will respond to a drug rather than using an animal as a surrogate for how a human will respond to a new medicine.
Under highly controlled lab conditions, the team are testing new drugs in the search for a cure to hepatitis B, a liver infection which kills 780,000 people annually. Hepatitis B naturally only affects humans and chimpanzees, making it very difficult for researchers to discover new medicines to treat the disease.
What we really want to be doing is to see whether you've got drugs that can actually cure things like hepatitis B. So how does that work in here? How can you look for that kind of thing?
We put the virus with the liver cells in the plates that we saw downstairs. The virus then will replicate within the cells, and we can measure how drugs affect the virus. We're really hoping there is going to be a breakthrough that will show the way to curing this virus, that will mean that patients will be able to take a treatment for maybe only a few weeks or months, rather than having to live on a lifetime of medication, and that's our goal.
As well as replicating individual organs in isolation, the next hope for researchers around the world is to create models of all the major organs and to link them together to examine how the whole body responds to drugs. The hope is that this global movement could speed up the search for treatments and cures for some of the biggest diseases facing humanity today.